algebraic fractions. Here is the thought process when we have to deal with algebraic fractions. The first thing we always do this first, is factorise. Always factorise first. That's the first thing we do. Then the only other thing we do is this. We only cancel, I can't think of a word for it, so I'll just put them there. Complete parentheses, not parts of them. So what do I mean by that? Well, this one's already factorised, of course, because we just have one term on the top and bottom, so that's fine. And cancelling, we do it to our heart's content. So a goes in a cubed and things like that, and we end up with that. That's probably the simplest type of algebraic fraction that we would have seen, that type of thing. But then we get something like this. And of course, the first thing I have to do with this is what? Thank you. Wow. I would have thought everyone got that answer. I only said it, how many times did I say it? Always factorise first. Always factorise. Yes, factorise. So what do we got? Top of the fraction, we've got some common factors. Got some common factors on the bottom as well. Difference of two squares on the top. And there we go. Now, once it's completely factorised, this is what I mean by complete parentheses. It's got to be identical. And we can see we've got p minus q. They can be cancelled, as well as the a's, of course. And we're left with p plus q on 2. Oh, multiplying fractions. Now when we're multiplying fractions, what's the first thing we've got to do when we multiply fractions? Factorise. Thank you. See, some of us are learning. Always factorise first. Always factorise first. Ooh, which factorisation would I do first? Probably the difference of two squares. That looks the easiest one. And then we've got trinomials. So let's see if that's what I did. Was it that one? Yes, it was. 3x plus 1, 3x minus 1. Then the trinomial. Now, of course, if you're a little bit confused and struggling, although this one's really easy, because of course 3 is a prime number. 1's not actually a prime number, but it only has one factor, so it makes it really easy, because it's got to be going to 3, it's got to go into 1, so I know it's going to be 3x and 1, it's just where the plus and minus sign is going to go. Okay, what do we got? Wow, lots of things cancel here. X plus 1 with x plus 1, 3x plus... Everything pretty much cancels to leave us just with 1. Okay. Division though, of course, is different. So with division ones, what's the first thing we do? Sorry, what was that?
You flip one of the fractions.
No, you factorise. You always factorise first. But you are right. I'm going to flip it as well. Because we don't divide fractions. It's just too complicated. So we turn it into a multiplication. We invert and multiply, or flip it and multiply. Okay. Which one will I do first? Probably the AB minus 2b squared. It's just a common factor. Then I've got a trinomial. Oh, it's actually a perfect square. A minus 2b all squared. There we get cancelling. We've got a's, b's, the a minus 2b's. And we're left with that. 1 on 2a, a minus 2b. Adding and subtracting of fractions. Now we have to deal with something differently, don't we? When we're subtracting fractions, what's the first thing we do? Factorise. Very good. Always factorise first. So let's play with this. What do we got? Well, the tops are not going to factorise, but I'll still whack parentheses around them. Makes it easier for the cancelling, if there is any cancelling. There is no cancelling to be had. So my thought process when I'm doing this, I draw in my vinculum, and then I create my denominator. Now, my thought process is this. If it's not there, put it down. And that's how I create the denominator. So all I do is I work from left to right, and I go, well, A, it's not there, I'll put it down. A minus 1, it's not there, so I'll put it down. A minus 1. It's already there, not a problem, keep going. A plus 1, it's not there, put it down. There's my common denominator. So that's how I create a common denominator. Now I need to create the numerator, and my thought process is, well, I just compare the old denominator with the new denominator and simply say, well, what's different? How did it change? So the old one was a minus 1. I now have a minus 1, a plus 1. What's different? The a plus 1. Well, that must be what we multiplied the numerator by. So I get a plus 1 squared. Now we've got minus, it was a plus 1, it's now a minus 1, a plus 1. What's different? It's the a minus 1. I get minus a minus 1 squared. Okay, what's the next step? So, sorry, anyone? What? No. factorise, because we now have something that's not factorised. And we always factorise first. So before we do anything, we factorise. So we factorise it. Now, how do we factorise something like this? We can look at for patterns. Of course, yeah, I could expand the whole thing out and then tidy it up. But if we notice patterns, we can save ourselves a heck of a lot of time, because you'll notice we've got a perfect square minus a perfect square, and basically the perfect squares are the same, except one's a plus and one's a minus. Now, I know the perfect square, a squared plus 2ab plus b squared, and the other one's going to be a squared minus 2ab plus b squared, so the a squared terms are going to disappear. So instead of having twice the product, I'm now going to have 4 times the product, because the minus minus. 4 times a times 1, bang, I could go straight to 4a if you spot the pattern. If not, fine, yeah, just expand the whole thing out. Got it. Now, let's see. Oh, a will cancel with the a. We have our answer. 4 and a minus 1, a plus 1. Ooh, addition. First thing I do here would be what? Factorise. Whilst the first 2 fractions are already factorised, the third one is not. Difference of 2 squares, so let's do that. Okay, draw the vinculum in, create the common denominator. If it's not there, put it down. X plus y squared, not there, put it down. X minus y squared, not there, put it down. X plus y, it's there. It's inside the x plus y squared. Now, when you have 2 things but to different powers, it's the highest power that you need. So I need the squared there. And then the x minus y, well, it's there, we're fine. What's different? First one, the denominator was x plus y squared, it's now x plus y squared, x minus y squared. X minus y squared is different. Plus, what's different? X minus y squared, x plus y squared. X plus y squared is what's different. Put it down. Minus, what's different? Hang on, they were only to the power of 1. It's now to the power of 2. Therefore, I must have multiplied it by the power of 1. So x plus y, x minus y. Yep, I could expand the whole thing out. Or, there we go. Perfect square plus the perfect square, but this time we're adding. So I'm going to get 2x squared, 2y squared. I'm going to get twice the squared ones. The middle term is going to cancel out. But now we're subtracting twice the difference of 2 squares. So I've got 2x squared. I'm going to take away 2x squared. That's going to go. I've got 2y squared, but then I'm going to have minus 2y squared, so it should be 4y squared. If you play with patterns, you can get the answer quicker. But if you find yourself making mistakes with that, well then, yeah, put more working out down. Write the whole thing out and see what it does. And there is no cancelling there. Okay, so there's our quick little recap of algebraic fractions.